I'm going to talk a little bit more about the practical realities of getting data into those equations and about actually how we can actually link suppliers to consumers. There's a few more pictures in mind, not very many formulas. Very happy to take questions, but we're trying to get a bit more of a practical practitioner's view of actually how to get data in and how to get it into a form that can be used. So no good data presentation can start without the fact that we're all drowning. We don't need to dwell on this, but the amount of data that I'm seeing, just every week, it goes up in orders of magnitude, to be honest. So managing it is a big deal for all of us. So let's talk about this. So before I get into this, quick show of hands. How many people consume data? How many people provide data to others? How many do both? Okay. So let's have a look at this slide. So a little bit of a test for you. Who am I talking about on this slide? So we're looking here, we're in a data-driven world. We know that getting data to people is hugely important. And if you want to have it at your fingertips, you actually have to invest in that. We also know it's hard. It's very frustrating. We'll get into some of the pitfalls later on, but it's really difficult to get a team to actually focus on somewhat, frankly, and let's admit it, mundane operational processes to make sure that your pipelines are working every day. How do you get people that care enough, that know data enough? How do you actually get the job done? If you're in the infrastructure world or you spent any time there, there's a good analogy with networks here. If you run the network in a major bank, you can only ever feel pain. No one appreciates you when you're working, and when you're down, everybody hates you. The same is true with data pipelines largely. There's always screaming when they're not there. There's not so much appreciation in getting the data there, and it's a big part of the job as we go through this. And these things are expensive to build, but are they differentiating? Well, I'm sure some companies believe they are, and the best do a fantastic job. A lot of companies don't, though. A lot of companies are ill-equipped to do this. A lot of companies are frightened to do this. So you're in a situation that if you don't keep up, you hurt your business. If you do keep up, it's a cost or an expense base that you have to manage, because all you're trying to do is to get to that very last piece to actually do the analysis, generate the signal. And margin pressure comes back. It only takes a good recession before everybody starts thinking about the cost structures. I asked a question at the beginning of this. This slide, most people assume that this slide is about consumers, and it is. But it's also about suppliers. We sit in the middle, as you'll see later on. But the trouble is that suppliers also have a hard job. Now, I don't have a lot of sympathy being on the buy side of this data business for a very long time, and I've also been a supplier. But suppliers face similar challenges. How do they keep up with the technologies to get the data to us in a way that actually makes sense to us? Why do I have to keep investing in all of these different technologies? Because the clients want it in a given way. Well, there's an answer there. You want to be paid. But it's still an overhead to the suppliers to do this, just as it is for all of us to connect into individual suppliers with a multitude of ways of doing things because they're just being helpful. So 2 seconds on the major trends. You must have seen a lot of these type of pictures, to be honest. Data is getting bigger and bigger and bigger. Extracting signal is becoming more difficult. Keeping bias out of the data, who is neutral, who is not, is becoming a bigger and bigger deal. How do you get data that you can trust in a way that you can manipulate? How do you get full provenance of that data? How do you prove that you've actually got the best you've got and that you know where it came from? Pipelines. We've all got a lot of these. So let's talk about inefficiency quickly. As a consumer, most of the business is about getting the data in and going through a number of basic steps. If you actually look at what the definitions are in the public space, you'll see that 80% is a recognized number, anywhere between 65 and 80, depending on which study you read, that says a lot of it is about doing the plumbing. That plumbing is not easy, it's not glamorous, it's hard, but it is 80% of the time. Even if you assumed it was 60% of the time, wouldn't you rather be doing data analysis? Well, actually, there is a group of people that actually enjoys doing the first bit, and that's great. We have a lot of them in our company too. But at the end of the day, companies in the open space, commercial, are not really focused on trying to get the data in. They're trying to focus on getting the data out and into a signal that they can use in the most cost-effective way. So it's not that these are easy tasks. They're not valuable tasks, but they are non-differentiating tasks. The job is actually how do we make sure that we can get that really easy from the consumer's perspective, really easy from a supplier's perspective, and make sure that we can join the two ends of the spectrum here, which is suppliers and clients. So pipelines aren't just a technical problem. The problem that you have with pipelines is suppliers and technology and contracts and building relationships. How do you actually get the data? If you're in a big organization, there's probably somebody that does this for you. But if you're going after a small data set from a small Chinese company, how are you going to do that? How are you going to go after the really big ones that believe that actually the suppliers, hey, we give you the data, we set the terms. How are you going to negotiate those relationships? So it's not just about getting the data in fast. It's not just about connecting to the right technology pipe. It's about actually managing the suppliers themselves. And then this is a sort of a joke in my family. You know, a puppy's not just for Christmas. That's a standard joke. It means that something lasts forever. So a pipeline isn't just for Christmas either. You want to build them, you want to get as much data, you end up with thousands, tens of thousands of these very quickly if you're ingesting large amounts of data. And they all have to be curated. They all have to be looked after, they all have to be run, and they all have to be fixed when somebody changes the schema without telling you. And you've got to deliver it. So internally, you're probably lucky if you're in an organization, you can put it on an internal site, maybe you're going to a NAS device, maybe you go to a DB. Suppliers don't have that luxury. Suppliers have to do all of it or none of it, or you as a consumer has to bend to actually do this. And that's why we see a multiplicity of different types of connections, techniques, and tools. Clients are different, bless them. Some want pull, some want push, some want query, some want all, some want it this way. It's fair. People want an easy way of ingesting data. You've got to find the right balance to give the right tools to the right folks in your organizations to do the job. The trick is the left to the right. Anything in between, and I'm including data analysis as well up to a certain degree, is overhead. How do you get data in appropriately, quickly, regardless of the techniques? Obviously, I represent Crux. We're here to try and help that problem. We feel that problem. Many of us have been in the industry practicing and surviving this problem for years. But the key point is to keep the client in mind. We have to get data in the right form to clients so that they can use the data in the way that they want to get value out of the license fees they've paid, or indeed to deduce signals from open data. So how do you think about this a little bit differently? Well, for the data suppliers, you have to think about what they need. So they need to be able to deliver. They need to run trials. How difficult if you guys found it to actually find anyone to tell you what the schema is of a new data set before they force you to buy it? How difficult is it to get it in exactly the format that you want? How do you meet the expectations if you're a provider of the operations teams on your consumers, making sure the data is always available for you? How do you make sure you keep up? We had a great conversation with one of the other partners outside about the access of databases. Almost feels like Back to the Future in terms of access to data. How do you keep up with that if you're a small supplier? How do you keep up with it if you're a big consumer? How do you get more flex in your pipelines? On the consumer side, you really would need one throat to choke. In an ideal world, if you didn't worry about competitive pressures, you want the data in the same way, guaranteed, so that you can load it. You need the right technical expertise on the data that's coming in. How many of you have dealt with suppliers where the supplier actually doesn't know their data? I know I have over the years, and I work for a big data company. How do you make sure that you're scalable? Is your infrastructure team? Maybe you are the infrastructure team. How do you make sure that you're there for the future, that you can really survive, that if there's a big bloat of data coming in? I mean, I've seen personally recently, some of the files that we're downloading and loading are like 130 gig. That's not huge, but it's bigger than the average data set. How do you do that reliably every day on multiple systems? How do you make sure that you get the data in the right format for your consumers? How do you make sure you keep up? So in reality, we sort of need an electric grid. We need providers and we need suppliers, basically to publish data. We need a mechanism to cross-connect that to the individual consumers. And we also need to recognize that consumers are also providers. We've seen in certainly our business Very many of the companies that start as consumers only recognize they actually have value in their own data sets and want to get those to market. Do we expect companies, commercial companies, to start building distribution networks and start basically working with as if they were big aggregators? I somehow believe there's a different model that's required. So let's talk a little bit about the engineering. Time and effort. So engineering starts with time and effort. How do you get the data? Well, the way we view this is pretty easy. It's a very easy model to think about. It's a difficult one to implement. You've got supplier engagement. You've got to have conversations with suppliers to get the data. You've got to analyze that data. You've got to work out how to load it. And a lot of that, in terms of the time and effort, is often driven by the size and complexity of the data set. I get asked a lot in our business, how long to onboard a data set? Or how long to onboard a data set is literally how long a piece of string is. It depends on frequency, complexity, number of data frames, can I get access, will the supplier give it to me? There's a lot of considerations when you start thinking about how to build a team to do this. But if you're doing your own pipelines, you have to do this in one form or another. You've then got the hardcore data engineering. How do you make sure you've got an infrastructure to process the data? How do you make sure that you sense the data the instant it's available? If your business is time sensitive and you believe that you need to react quickly and your competitive edge is driven by processing quickly, you better have a good sensor infrastructure in place. You also better have a good pipeline infrastructure in place, and you better have a good distribution infrastructure in place. Everybody's doing this again and again and again. And I love the ETL tools. I really think there's some fantastic stuff out there. But those are tools that we use as well. We need those sort of tools to help us onboard data. But there's so many different ways of onboarding data, and there's always nuances in what you do. You can't avoid having a really good engineering team sitting beneath this to get your pipelines working. And at the end of the day, there's the puppy again. How do you keep all of this working in production, day in, day out, 24/7? Just when you think you want to take the system down, you find a client wants you to keep it up. That long weekend of analysis that you didn't know you were impacting. How do you make sure it's there when they want it? And underpinning all of this, you've got to get the right team, you've got the right quality, you've got to get the right people, you've got to get the right tools, and you run the process. This is a business. Now, whether you're running a business internally or you're going to someone like us to actually help you with that, it is a business. This is not a hobby. You cannot treat data ingestion as a hobby. If you do, you're not doing this seriously, and you're going to end up, frankly, probably in a train wreck, because this stuff it gets harder and harder the more scale you put into it. It's almost impossible to get into this business by doing it on a casual basis. So I quite like the play on causal AI versus casual AI that's coming from this. Quick peek at us. So what have we done? Well, pretty standard classic engineering, to be honest. We have a strong component and abstraction architecture. We may brand it a little bit differently than what you guys have got, but I have a fairly robust ingestion pipeline, which I call Crux Deliver, which grabs everything in and pushes it out. We have clear adapters to push things into various distribution mechanisms. It took us a while this is everybody when you look at this goes, yeah, that's a standard architecture. But when you're in up to your elbows or you're doing this to start with, you tend to get seduced by other pieces of technology, the big data set that's there as well. The core of our engineering is solid engineering. It's not the newest tool on the block. We use the right tools for the right job. The core here is to make sure you get the right abstraction, that you can run pipelines. Pipeline is a pipeline from my perspective. I want to run the best, the fastest, the easiest, the most configurable. But I need it in a way that I can take the output and repurpose that output. This is not difficult CompuScience to get your head around. It is quite hard engineering to get right. And we've used this to our advantage. We've recently introduced publishing our data sets actually directly out of our file-based core into databases. Relatively straightforward because of the abstractions. And it's going to keep us nimble, and it protects us in terms of actually new distribution technologies coming along. Some will be flavor of the year, some will stick around for a long time. And as we go through this, we want to make sure we've got an architecture that can flex along with it. Event architecture. This feels like, and I was talking to one of the guys outside, and he was talking about databases. Now, we don't actually, pause for effect, we don't use a core database in our central system. We thought about that, and we moved away from it. The problem that we face is making sure that we can entitle data. The easiest way that we structure our data, we believe in data sets. We group them together, and we obviously call it a Crux delivery unit as our product that we use to group data sets and then data frames underneath them. We process those really well, and we entitle our clients at a data set level. Now, many of you don't have to face entitlement problems, but some of the bigger organizations do. They want to trace the entitlements of their data across their organizations. A lot of the really big banks are centralizing that function, are trying to be in a position where they run their own exchanges, in essence, where they can get the data in one place, get economies, and distribute that data out to their various divisions and keep quite good track on who's using what, not only from profitability accountability, but also to make sure that they're actually entitled to use that data. Because again, suppliers and companies do not have singular relationships. Many of the big suppliers have multiple relationships with various divisions of the bigger players. So you've got to keep track of this. So what we do is we get all the files, and we call that Crux Hub. We put an event architecture around it, and we'll come back to some of the lessons we've learned as we've got through this journey of actually making sure that we try to have an event at the lowest level so that we can actually group them together and do processing based on what our clients need. Now, that sounds very generic, but it's the equivalent, the hardcore example of this is if you've got a data set that's made up, say, a dozen frames, a fairly small one, then some clients want to be notified when all 12 have actually completed. Some clients want them run in a very specific order, and some clients only want to be notified when number 6 is finished. So from an engineering perspective as a supplier, I need to go down to the lowest level of this to try and support them in that endeavor. So I actually try to make sure events come out at the lowest level I can, which is effectively at the frame within a data set level. And then we group those together, and we do post-processing off the back. So what you're seeing here is obviously a very high-level architecture, but we have a bus, we have a sensor infrastructure that checks on websites if we're not getting a defined feed. We have a mechanism for enclosing interesting provenance of, say, Chinese supplier loaders that have to be run in a very secure VM, just in case, in order to pass security muster. We have a number of different techniques for doing this, and then we basically publish that into our pipelines. And we optimize how our pipelines process, and we group the output, and then we repurpose it in order to be transmitted to our clients. Schemas. Who loves schemas? Schemas are there just for one thing, yeah? Being changed when you're not looking. So the way we've approached schemas, okay, so we have output resources. Now, whether that's a file or whether that's a database or whether it's a stream of data, we tend to define that in a classical sense as a frame of data. So a very specific structure for a given moment in time. What we do is we define input and output schemas relating to this. We actually show the relationship between them. Now, we've stumbled on this historically. So we've put in the fact that we didn't put precisely what was in the output schema. Some of that was hidden in our processing, and we've just remediated that. Because knowing exactly what's coming out, exact provenance based on data, if you're a data business, you need to run yourself on data. You need to run yourself on configuration. You cannot put this in code and expect it to be exposed to clients in some other way. You need to be able to actually describe the schemas and processing through. If it was just this would be straightforward. Unfortunately, we have dictionaries to take into account. What goes into the schemas? Does a dictionary from a supplier, is it always right? We deal with some of the biggest data sets on the market, and within that, it is sometimes beyond belief that some of the biggest providers can't even get their own ID name spelt the same way in multiple fields. Now, a lot do, but it's not uncommon to actually have a dictionary that's actually faulty from the supplier, even if they provide one. So regardless of this, you need a way of describing your data to get meaning out of it, to get insight from this. So you actually have to get a dictionary and relate it to your schemas very, very well, or you're exposing yourself for when this happens. They change it. If life was static, this would be hard, but not impossible. So the second frame comes along. If you guys are loading data into a database, do you go back and do a database conversion? Highly unlikely. You might in some cases, you might build a view on top. But the reality of this, and typically, is you end up with doing another table and trying to remember that they're related. So you've got to keep traceability between the frames. And then here's the trick. So a little bit of the secret sauce. Just relate the output schemas. If you can track your output schemas in the same way as you track your input schemas, you have an ability to provide an installation layer to yourselves. So this is what we're doing. This is how we're going to basically put schema protection in place for our clients and our suppliers. So it's both the suppliers would benefit because they can do their release schedule as they wish, and the consumers can move on the adoption pace as they wish if you can provide complete schema evolution protection, which we believe this can. Okay, so what have we learned? Well, it's been a busy 6 months for me in the company, and I would bring out a few things. Pipelines are not the be-all and end-all. They're extremely important, but they're the start of the problem, start of the solution. They're not the end goal. There's no such thing as a standard. There really isn't. I mean, I've had a situation recently where we were checking effectively the control structure, and we found a bunch of frames for probably the biggest supplier out there, and there was no data. So obviously, it's our code. We check, no, we go back to the supplier. Can you tell us, these data frames, you don't seem to be supplying them. And these are like 20, maybe 25 amongst 7,500 for this one supplier. And their comment was, no, sorry, no, we never had data for those. But why are they in the spec? Well, we might have data for those. Are you telling me that they might appear at some indeterminate time in the future? Yes. And when you start looking, you start seeing other suppliers with the same basis. How do you process that? How do you make sure you've got the control mechanisms in place to spot a new frame appearing and then do something about it? Because it needs to be a conscious decision. Subconscious, you can do the engineering to automatically create the frame and the pipelines, but how do you know what that data is and how do you do something with it? Insight. If we think pipelining gets hard, gaining genuine insight for what the data really is much harder. What is this data set? Many data engineering groups become a basis of your biggest driver in life is to get the data. Your client wants it. They want it yesterday. Get it now. And you don't have time to do the thought process. We go through a process where we try to do that onward, catch the wave of engineering to get things on, but then we go back and we tidy up. We go back and look at what that data sets are. And there's always an ever-increasing backlog there. But getting insight from the data is significantly harder than doing the engineering to onboard that data. And then contracting, for those of you that have to do it, is, frankly, they're doing someone's work. This is very hard when you have an intransient supplier, or you've got a really good one but doesn't have a technical department to actually help you. You've got to get all of these sorted out for data. And then just when you think it was safe to go back in the water, and you have a conversation with a client or your internal supplier about how to get the data, you find that has nuances too. We're going to show you in a second, we've actually done quite a bit of work with Snowflake. So that's easy. You talk to the first client, fantastic. Talk to the second client, yes, we want to try this out. You talk to the third, and then you ask that little question at the end, where are you running it? And you find it's in a different cloud, and you have to fix that. There's always nuances in terms of distributions, even when you think you've got this nailed. So if data insights are 101, technology is 102. And 102 for you, if you Google it, you'll find it's basically a banking response for the systems down. So hopefully that's not an analogy for this. So let's have a look at this. Not everything is a big data problem. Okay? That's linked to the next one, is not every solution needs a big data tool. It's very easy to be seduced into thinking that because you're doing data and because it's really big, that you need all the bells and whistles, you need the Spark infrastructures, you need to have dynamic dispatch. It's just not true. The baselines of hardcore pipelines is solid engineering. Now, you can do it in many ways. We've chosen event-based structures to do it, but you don't necessarily need state-of-the-art or bleeding-edge technology in order to do things. If you're doing analysis, I will give you that actually, on the analysis side of the house, perhaps you do. Perhaps bigger engines where effectively data stores that can span multiple petabytes. I get that. But for ingestion and pipelines, use the right tool. Mature technologies have their place. Okay? It's not bad to use Excel with an ODBC driver to look at your data. Okay? It's not bad to use MySQL for your corporate reference data. Okay? You might want to use Cassandra in other places. You might want to use BigQuery. You might want to use Snowflake. There are many options for you to do. But don't throw out some of the mature technologies to build your pipelines and to build your infrastructure. There's a lot of goodness there. It's been there for many years, and it's a good risk bias against some of the newer technologies. Focus on your own data. What are the atoms? What do you process? I mean, genuinely, we've gone down the stack, up the stack. I have more arguments with my data staff and tech staff about the structure of how we process than necessarily any of the data we process. It's really important to understand what your basic atomic unit is that you're processing and optimize around that. Certainly as a supplier, as an important piece of the pipeline infrastructure, I want to be really well at the very smallest thing we do, and I want to roll that up later. Which goes on to the next bit. Name early and bind late. Get your naming structures sorted out up front. I would defy anyone to onboard something like the larger data sets out there, the risk models, the financial fundamental models, without getting a naming structure agreed. And it sounds silly. It's really important. You need to be able to make your data sets digestible to your consumers. You need to make sure they can actually be pulled down and found. Discovering the data you've onboarded is almost the biggest problem as onboarding it in the first place. Making sure that you have a decent catalog that people can actually programmatically access so they can find the right table with the right data in it, or find indeed the right field inside the right file that they downloaded for a delivery last year. Or how do you handle your histories? Really important to do that, get the naming done straight, and then to bind your actual runtime infrastructure to that very late in the game. The more you can do that, the more flexibility you get. Lies, damn lies, and column names. I'm sure we've all lived this. I will absolutely execute the next supplier that puts double quotes in a column name. You've got to actually manage this stuff. Unfortunately, this is the real world. It's mind-boggling to me how many suppliers do not take into account what the client is going to see. Now, I'm a proxy for the client in many cases. I take the data in and I cleanse it. I feel this pain. I feel your pain on this. We've got to get better education out there in the industry about what's acceptable and what's not acceptable to make everyone's life just that little bit easier. No matter what you do, your architecture needs to flex. No matter what you do, you'll make wrong decisions. The only guarantee in life is whatever you built would not actually work completely for every use case you've got. Make sure you've got a process in place that allows you to flex. Data duplication is not solving the client's problem, which is a bit of an interesting statement from us as we actually make sure that we move data, we duplicate data in essence, from the supplier all the way through to the client. It's necessary. There are better models, but everybody has to get to those better models if they want to do it. We want to help the industry have a lifeblood to get that, and then also support more sharing options. Ability to actually share, not duplicate data, ability to query it. But you've got to get the data in order to query it. That's where we come in. And then two last points. Dictionaries, a little bit like earlier, you must curate them. You can't, they just won't organically happen. You need to understand the cross-referencing. You need to be able to make sure that you know how to join two different data sets. Most of the bane of people's lives are, I got this set from Bloomberg, I've got this set from MSCI, how do I join them? How do you get that sort of information out there? How do you provide that information to your users? And the last one, a little bit tongue-in-cheek. Yeah? You can't automate stupidity, but you can actually use automation to spot stupidity. Make sure you clean your pipelines. The data coming in, there's an old adage in data architecture, which is get the data right at source. If it's not right at source, clean it as fast as you can as it comes in. Okay, last slide. Guide to data karma. Keep it simple. It's really, really hard. It's very easy to get complex. Most of the people in this business can handle complexity, and there's a tendency to overcomplicate the answers. Make the engineering as simple as you possibly can. Question it. I have scars for questioning it with my own teams, but it pays off. You're able to build components that will scale with you. Consistency. Wherever you can, try to make it consistent. And this sounds like motherhood and apple pie, and it is, but it's so true. If you are good at processing pipelines, you better be able to define pipelines consistently. If you want to be able to distribute data, you better have a plugin infrastructure that allows you to do that, or a very big engineering budget, and a lot of tolerance, and probably a lot of value. And the last point is, as being obviously a Brit, I'm fond of this slide in terms of keep calm. Be paranoid. If you think it can't happen in the data sets you're processing, it will happen. Every day, I feel like I'm saying, I can't believe it. But every day there's something that jumps out, and you need an infrastructure that can support that fright moment, has a way of coping with it and plugging it back in. And I think I've only gone 1 minute over. So thank you, happy to take questions, and there's an office hour at 3:15 upstairs if anyone wants to talk.